Alright viewers, welcome back. I'm still discussing integration. In the previous session, I've established the general integration principle. Now for this particular session, I want to establish what is called standard integrals. Those things I will expect you to recall with me as we solve questions. Very quickly, on the screen you can recall some of these derivatives we had. That's just what I want to bring back. If you differentiate a constant, you have 0. Okay? Alright. Now if you differentiate x, you have 1. Meaning if you integrate 1, you have x back. So let's take that as a standard function. So y equals to f of x equals to x, just a variable now. You recall that the derivative dy dx is equals to 1. Meaning if I have integral of 1 dx, that's like saying 1 times x, which will give you dx alone. So I have integral dx. Okay? Integral dx will give me x plus k. If you integral dx, that means integral of maybe something like 1 dx. Because we cannot write the 1. But we know that there is an unseen 1 there. 1 times dx is dx. So integral dx is x plus k. Alright, the other ones I want to recall are for the trig functions. Now if you have f of x to be equals to sine x, you have f of x to be equals to sine x. So your derivative dy dx, you can make reference back to the differentiation video. Now if you differentiate sine x, you are going to have cos x in maths. Okay, so what this means is that the integral of cos x dx is a standard integral. You just need to recall what the derivative was. It's a standard integral. Okay, so integral of cos x dx is going to give me the sine back. So I have sine x plus k. If you differentiate sine, you have cos, meaning if you integrate cos, you have sine back as a standard integral. Okay, the next one is now f of x is equals to cos x, the second trig function we had. Now the derivative of cos x dy dx will give us minus sine x, meaning if I integrate minus sine x, that's when I'll have cos back. But most of the time in the question, you notice that you will be asked to evaluate the integral of sine x, not minus sine. Listen to me. You differentiate cos x, you have minus sine, meaning integrating minus sine will give you cos back. But if you are now integrating sine without the minus goes back to the answer. So integral of sine x dx will give me minus cos x plus k. Differentiate cos, you have minus sine. Integrate minus sine, you have cos. If you are not integrating sine alone without the negative sign, the minus goes back to the answer. So integral of sine x dx will give you minus cos x plus k. Alright, fourth one is y equals to tan x. Okay, and the derivative of tan x dy dx, you can make reference to the differentiation video. I've said it before. If you differentiate tan x, we had sec square x dx. Sorry, sec square x. Sec square x. That is the derivative of tan x. Meaning if I pick this and integrate, integral of sec square x dx, I'm going to have tan x back plus k. Because sec square x was the derivative of tan x. If you are integrating sec alone without the square, of course at this level is completely not expected. You cannot be asked to integrate sec x dx at this level because it's not a standard derivative of a function. That one will demand a lot of calculations and the rest, which at this level is far beyond you. The standard derivative for tan is sec squared, not just sec. So you'll be asked to integrate sec square x dx. That will give you tan back. Alright, so the fifth one we have y is equals to 1 over sine is what is called cosec x. Alright, now if you differentiate cosec x dy dx, we had minus cosec x cot x. Minus cosec x cot x. Meaning the integral of that minus cosec x cot x will give us cosec x back. Okay, but sometimes they can give you just cosec x alone, cot x alone without the negative sign. So that means the answer will go back to the original function. So we have minus cosec x plus k. Differentiate cosec x, you have minus cosec x cot x. So integrate that minus cosec x cot x, you are going to have cosec x back. But if you are not integrating without the negative sign goes back to the cosec x. And of course the sixth one, we have y is equals to inverse of cos gave us sec x. Inverse of cos gave us sec x, meaning the inverse of cos gave us sec x. So the derivative of sec x, like I pointed in that video, is sec x tan x. Don't forget. If you differentiate sec x in math, you have sec x tan x. Meaning if you integrate sec x tan x, so integral of sec x tan x dx is going to give you sec x back plus k. And finally, for the seventh standard integral, for now, if we have y is equals to cot x, which is the inverse of tan, we call it cot. Derivative of cot x dy dx gave us minus cosec square x. You can make reference to that video. When you differentiate cot x, you have minus cosec square. So this implies that the integral of cosec square x dx, you are not integrating without a negative sign. That guy will go back to this guy. So you have minus cot x plus k. Those are the things I choose to call standard integrals, because as we proceed in this lecture, when we are trying to solve one or two things, I'll need you to recall this. In summary, differentiate sign, you have cos, so integrate cos x will give you sin x back. Differentiate cos x, you have minus sin x, so integrating sin alone without the minus will take the minus back to the cos. So integral of sin x dx will give you minus cos x plus k. Differentiate tan x, you have sec square x, so the integral of sec square x dx will give you tan x back plus k. Differentiate cosec x, you have minus cosec x cot x, so the integral of cosec x cot x without the negative sign will take the negative sign back to cosec, so you have minus cosec x plus k. Differentiate sec x, you have sec x tan x, so the integral of sec x tan x will give you sec x back. And also the derivative for cot x is now minus cosec square x. So integrating cosec square x now without the minus will take the minus back. So these are what I call standard integrals. Integral of cos x dx gives you sin x. Integral of sin x dx gives you minus cos x plus k. Integral of sec square x dx gives you tan x plus k. Integral of cosec x cot x will give you minus cosec x plus k. And integral of sec x tan x dx will give you sec x plus k. And also integral of cosec square x dx will give you minus cot x plus k. These are standard integrals which I want you to be conversant with, because I'm going to make reference to them. And also we now talk about what is called the integration of function of a function. When I discuss differentiation with you, of course, one of those rules we did for differentiation was the chain rule, which is also called function of a function. Alright, so in this integration now, I'll be showing you how to evaluate integration of function of a function. I won't show you product rule for integration, because product rule for integration here is called integration by parts and is beyond the scope of this work. Okay, so the product rule we had in differentiation as f of x equals to uv. Derivative is v du plus u dv. Keep this one constant, differentiate this one, plus keep this one constant, differentiate this one. That was for differentiation, and that level it was okay. But at this level, product rule for integration is called integration by parts, which is beyond the scope of work here. Alright, so I'll be doing integration of function of a function, which is chain rule, and that's what I'm about to resume now. Alright, so on your screen you can be asked to evaluate the integral of 2x plus 1 raised to power 5 dx. We are to evaluate this integral. This integration of function of a function. 2x plus 1 raised to power 5 is a function of a function, a linear function inside the power function. Alright, so we do the same thing like we did in differentiation. We substitute u as 2x plus 1. So I'll say let u be equals to 2x plus 1. I'll differentiate du over the x. Differentiate 2x, I'll have 2. Differentiate 1, I'll have 0. Okay, so that one is gone. At this point, I'll cross and multiply. Okay, so I'll cross and multiply. I'm going to have du is equals to 2 dx. And I'll make dx the subject. So that will give me du divided by 2. So I'll get back to my original question now. So integral of 2x plus 1 is now integral of u, because that guy is called u. Okay, raised to power 5 now, and the x now is now written as du divided by 2. you can notice why we needed to make dx a subject after differentiating, because we need to bring it back there. We can't have something like integral of u raised to power 5 dx where your variable is u and dx is now there. At this level is not accepted. That was why we made dx a subject from the derivative, so that we can replace it at this point. So this now equals to integral of u raised to power 5 divided by 2 then du. We can write a constant term outside, which is 1 over 2. Since 2 is under, it means 1 over 2. So we have 1 over 2 integral of u raised to power 5 du, which is 1 over 2. Now we now integrate u raised to power 5. We add 1 to that, divide by that. So that will give us u raised to power 6 divided by 6 plus k. So this is equals to 1 times u raised to power 6 is u raised to power 6 divided by 2 times 6 will give us 12 plus k. So we now replace, so our answer is now u 6 over 12 plus k. But we are not working with u, we are working with x. We are integrating with respect to x. That was why we had dx. So we replace what u was at u equals to 2x plus 1. That was what u was. So this u raised to power 6 will give us 2x plus 1 raised to power 6 divided by 12 plus k. That is what is called integration of function of a function. We have 2x plus 1 raised to power 6 divided by 12 plus k. Alright, I take another example. You can always play back the video as many times as you want to be able to get that explanation again. But let's take another example. Integral of 3x minus 2 raised to power 4 dx. We are to integrate this. It's still function of a function. Quickly, we let u to be equals to 3x minus 2. We differentiate. So that gives us du over the x is equals to what? 3. So I cross and multiply. I have that du is equals to 3 dx. So if I make dx the subject, I'm going to have du divided by what? 3. So I'll get back to the original equation and substitute 3x minus 2 as u. So I have integral of u raised to power 4 now, and dx is now du divided by 3. So if you write the constant out, you have 1 over 3 integral of u raised to power 4 du, which is equals to 1 over 3 into u raised to power 4. If you integrate that, you add 1 to the power, you add 1 to the power. So that will give us u raised to power 5 divided by 5 plus c. Okay, so this is equals to u raised to power 5 divided by 3 times 5 will give us 15 plus c. We now replace what u was initially. So u was actually 3x minus 2 raised to power 5 now divided by 15 plus k. That now becomes the integral of 3x minus 2 raised to power 4. We call this integration of function of a function. Alright, so the next example, you can always play back the video, don't forget. Alright, the next example I want to do is with trig functions now. So I have integral of sine 4x dx. You have to integrate sine 4x dx. Integral of sine 4x dx. Okay, it's still function of a function. Standard function is sine x alone, not 4x. So we substitute that guy 4x. So we let u to be equals to 4x. And we integrate. Sorry, we differentiate. So we have the u over the x is equals to differentiate 4x, we have 4. We cross and multiply. We have du is equals to 4 dx. Okay? Make dx the subject, we have du divided by 4. So we now go back to our original equation and have integral of sine 4x is now u, and the x there is now du divided by 4. So this is equals to, we write the constant term out, 1 over 4. We now have integral of sine u du, which is equals to 1 over 4 integral of sine u. Now don't forget, differentiate cos, you have minus sine. Integrate minus sine, you have cos back. If you are not integrating sine now without the minus goes back to the answer. So integral of cos, sine u du will give us minus cos u plus k. Integral of sine u du will give us minus cos u plus k. So this is equals to, we open this bracket up, 1 times minus cos u will give us minus cos u divided by 4 plus k, which is equals to minus cos u was what? 4x. So we have minus cos 4x divided by 4 plus k as the integral of that guy. This is with trig functions now. Okay? Also, I want to take another example. I have integral of sec square x 2x plus 1 dx. you are given this to integrate, which is possible at this level. Integral of sec square of 2x plus 1 dx. Okay, so we also substitute, we let u to be equals to 2x plus 1. So here we can differentiate du dx is equals to 2. Cross multiply, make dx a subject. You have your dx to be equals to du divided by 2. I hope you understand that by now. So I go back to the original question and now have integral of sec square 2x plus 1 is now u. Okay, so we have sec square u, and dx is now du divided by 2. So I'll write the constant out. I have 1 over 2 integral of sec square u du, which is 1 over 2. If I integrate sec square u, don't forget, differentiate tan x, you have sec square x. So integrate sec square x, you have tan x back. So if I integrate sec square u, I'm going to have tan u back. So I have tan u plus k. So this equals to 1 times tan u is tan u divided by 2 plus k, which is equals to tan u was what? 2x plus 1 divided by 2 plus k. Alright, this is how to integrate by using function of a function. That's chain rule. Alright, so that is what this session, I was actually trying to establish and also trying to explain so that you understand. You can always replay the video again and again. So in this session, I've established definite integrals, just you recalling your standard derivatives and also the standard integrals when you integrate those derivatives. And also at this point in time, I've established what is known as the differentiation or integration of function of a function. Alright, we're still not done with the tutorial. Don't go anywhere. In the next video, I'll be explaining what is known as the definite integral. And of course, I'll take you to the application of integration, talking about area under the curve. Don't go anywhere. I'll be right back. See you.